Let us look at some of the visualizations that we can use for comparisons. First of these is a bar chart. Bar chart is often used for distribution as well. But if you've got multiple values that we need to find, a comparison of bar chart is one of the simplest and yet most effective method that there is. I'll show you the data we have here. For example, if I'm trying to find which type of accent takes the most lives, and we need to see the frequency according to the Google results, then I can use a bar chart and I can say that skydiving claims 710 lives in a year on average, and elevators can take 575, and similarly, even knitting and blogging have a share of here, even though I'm not sure how blogging can cause some death, but there we have it. So again, we've got multiple years, you've got data that is spread over some time, and you need to see a change in how data is occurring. For this comparison as well, bar chart is one of the most effective ways that there is. Based on this change, I can also tell you that bar chart is used for stating the direction. So here we have graduation rates in most cities, and you can see that what the previous ones were 1995 to 2005 changed. So what I've only plotted over here is the difference between them, what it was previously and what it is now, and how much it has changed. Okay, so this would again give me a very clear-cut indication of how the trend has been changing from previous one to new one. These frequencies or these would indicate a pattern or a shift towards one direction or the other, or a complete lack thereof. The other thing that we can use is line charts. Line charts are very effective in showing relationships between multiple variables, and these again are the best or more suited to find the comparisons between multiple variables. So I've got some let's say one variable over here and the other variable over here, and I can tell you how the shift in this one causes a shift in the other one. Let's look at it in a little more detail. So I've got the whole year 2008 over here, and I can see that what the trend was in November, December 2007, and then how it was shifted in January 2010. Similarly, you can have different shapes of these line charts representing different relationships between multiple variables. So the same information can be given by that, or it can have this slightly rugged shape where you can have actual data plots and you can put them aside, or you can have this generalized shape where we can find the trend or pattern. And this is basically a sine wave. So you're shifting between values from 0 to 2 pi, and you're seeing how they change from one to the other. The other things that in case of line charts that we need to remember is using linear scale or logarithmic scale. A linear scale gives you the actual values that there are, but the actual values in some cases might be so many, that it may not be effective or useful to present them as they are. So in those cases, we need to sort of normalize data, and we find logarithmic scale instead of the linear. The logarithmic scale presents to us a more comprehensive view of the data without one value having much larger or being much larger than the other ones. There is one point to note, however, that in case you have categorical data, then use of line charts would be very pointless. Okay? So when you've got distinct categories, always use bar charts for comparison instead of line charts. There is no useful information that line charts can provide to you in case of categorical data. Similarly, another thing that you should not do is find or compare ratings of independent elements over time. So for example, you've got book ratings and you're categorizing different volumes of this book. So it would be pointless to have these book rating comparisons over time where the books themselves are different. So it's better to use bar charts in such cases instead of line charts. They never ever represent so much information that you lose the advantage of visual elements. Okay. If you look over here, that there are these overlapping areas and there are so many variables that you can't actually see what's going on. So the whole point of visualization was to make our lives easier. And we've made it so complex that it's not possible for you to differentiate which element was over there. You can see the same thing over here, that what these areas do not signify any useful information. So the whole advantage of visualization is lost. Now here you can see such bad color schemes used that nobody would like to look at it long enough to see what information it actually contains. So do not go for colors that can cause problem to people with color blindness or people in general. And again, you see that the color used in the front is yellow one is obscuring the one in the background. There may be more than one color, so I can see some different magenta color over there and so on and so forth. So there's no point in having such color schemes that they actually hide information instead of you providing you anything useful. Plus, these visualizations are not very pretty to look at, and for any user to be interested in extracting information, he needs to be able to instantly make out what is being said in the diagram.